Welcome to qnawire.
Hi, so here what we're going to have is a sample of a metal of mass equal to 135 grams at initially 153 degrees Celsius that is going to be added to a sample of ethylene glycol, so we're going to abbreviate it as follows, of 255 grams, which has at initial temperature of 25.7 degrees Celsius. We know that the final temperature for both of them is going to be equal to 38.2 degrees Celsius. And we want to calculate the specific heat capacity of the metal, assuming that all the heat lost by the metal is gained by the ethylene glycol. We also know that the heat capacity of ethylene glycol is equal to 2.43 joules per gram degree Celsius. So, with this information, what we know is that the heat that is going to be lost by the metal is going to be equal to the heat gained by ethylene glycol. For the metal, what we're going to have is mass of the metal times heat capacity of the metal times delta T for the metal. This is going to be equal to mass of ethylene glycol, heat capacity of ethylene glycol, times delta T for ethylene glycol. So the value for delta T for each of them, one of them is going to be positive, the other one is going to be negative. For ethylene glycol, this is going to be 38.2 degrees Celsius minus 25.7. So delta T for ethylene glycol equal to 12.5 degrees Celsius, and delta T for the metal, is going to be negative because we go from a higher temperature to a lower one. So finally it's 38.2 minus 152 degrees Celsius. So it's going to be equal to minus 114.8 degrees Celsius. I'm going to just put these values here, but we're going to proceed by solving the equation directly, and then we're going to replace the results. So the heat capacity of the metal is going to be equal to mass of ethylene glycol, heat capacity, ethylene glycol, delta T for ethylene glycol, divided by minus mass of metal times delta T for the metal. Replacing the values, heat capacity of the metal is going to be equal to mass of ethylene glycol, we said that was equal to 255 grams, sorry. Heat capacity is equal to 2.43 joules per gram degree Celsius times delta T for ethylene glycol is 12.5 degrees Celsius divided by minus mass of the metal 135 grams times delta T for the metal, that is minus 114.8 degrees Celsius. The result is going to have units. Here grams and grams cancel out of ethylene glycol, the degrees Celsius with degrees Celsius, and the units are going to be joule per gram degrees Celsius as well. And we end up with a heat capacity of 0.499 joules per gram degrees Celsius, or approximately 0.5 joules per gram degrees Celsius. So that would be all. Thank you very much and have a good one.